Hello, dear students. Assalamu alaikum. I'm Daud Virgil, your chemistry teacher. So today I will be discussing in detail the questions of worksheet number one, that is of the chapter rate of reaction. I will discuss in detail every question. I will discuss the steps and teach you the strategy how to attempt this question. Okay. So let's start with question number one. In question number one, as you can see, the apparatus has already been drawn, a gas syringe and a conical flask that contains dilute hydrochloric acid and magnesium in it. So we need some additional pieces of apparatus for this experiment. So which apparatus we will be needing? Obviously, we need a stopwatch so that we can note the time at different intervals. So we will be needing a stopwatch. And what else do we need? We need a measuring cylinder so that we can pour HCl into the conical flask, as well as balance in order to measure the mass of magnesium as it is evident from the question. So before doing question, always read the question first. It says that we need to have a fixed mass of magnesium and a fixed volume of dilute hydrochloric acid. For this, we will be needing a balance, and for fixed volume of dilute hydrochloric acid, we will be needing a measuring cylinder. So what we are left with then, a stopwatch. So we need these three things additionally. So which option has all three options? A. And it also says thermometer. We don't need a thermometer because we are not checking the temperature changes. So automatically these three options do not suit with the question. So I will simply put a cross in front of them. I'm eliminating these options. So we are left with only option number one, option number A, that is balance, measuring cylinder, and a stopwatch only. So A is the correct answer. Right. In question number two, a reaction has been shown between calcium carbonate and HCl. So the question is asking which change in conditions make the reaction proceed more slowly. So we have to focus on the condition that will slow down this reaction. I'm underlining the question requirement. Increasing the acid concentration. As we know that increasing the acid concentration increases the rate of reaction as particles are more crowded and they collide more frequently. So this will definitely increase the rate of reaction, but A cannot be the correct option. So we'll put a cross or eliminate this option. And option number B, increasing the size of the solid particles. Yes, this seems to be right because by increasing the size of the solid particles, we are basically decreasing the surface area. So this will lower down the rate of reaction. And since you know that decreasing the surface area actually decreases the area or contact on which the reactants can collide. So that is why the rate of reaction will decrease or slow down. So this seems to be the correct option. Let's look at the other two options. Increasing the surface area of the solid particles. Yes, this will definitely increase the rate of reaction. This is also not the correct option. And option number D, increasing the temperature. Increasing the temperature will, increase the kinetic energy of the reactants. So this is also the wrong option because this will increase the rate of reaction by, as there are more chances of successful collisions. Particles would collide more frequently. So this is also not the right option. So the right option is B, as this will only uh, slow down the rate of reaction. So this is the correct option. Okay, let's move towards question number three. What is the best way of slowing down the reaction between magnesium and sulfuric acid? Okay, magnesium and sulfuric acid. I'm just writing the equation for you. Okay, we have to slow down this reaction. Option A, adding a catalyst to the reactants. This will automatically increase the rate of reaction as catalyst lowers the activation energy by providing an alternate pathway. So A can also not be the correct option. Okay, B, diluting the acid used in the reaction. Yes, this will definitely slow down the reaction. And since we are decreasing the concentration, so lowering the concentration will slow down the rate of reaction as we discussed in the class. And this seems to be the true option. What about C? Stirring the reagents. So stirring the reagents means that we are, providing some external kinetic energy or motion. For example, if we just simply put some sugar into a glass of water and do not stir it, yes, it will dissolve after time, but the process will be too much slow. So if you stir the solution, then the reaction will take place quickly. So yes, stirring helps to speed up the rate of reaction. So this can also not be the option. If we talk about option number D, using magnesium powder instead of a strip of magnesium, yes, this will also increase the rate of, this will also increase the rate of reaction. Magnesium powder has a greater surface area as compared to strip of magnesium. So this will increase the rate of reaction. So this is also not the correct option in this case. So I will put a cross in front of it. So we are left with option number B, and this is the right option for question number three. So I'm, circling option number B for question number three. So yes, this is the correct option. Let's move towards question number four. In this, we can see that two experiments have been conducted, experiment one and experiment number two. So if you look at the volume of gas collected, experiment two has the highest yield of gas collected, that is 75 at 300 seconds for both experiment one and two. So we have to look at the thing which will, increase the yield of the gas collected. So by looking at the options A, B, C, and D. Okay, we just have to make one change according to the question. I'm just, highlighting or underlining the requirement of this question, which one change in condition to experiment one give the result for experiment number two. Yes. So let's look at option number A, a greater volume of acid is used. A greater volume of acid will, give the same yield because the moles would stay the same. However, this will not have, impact on the yield of the gas. But if we change the concentration of acid, yes, this will definitely have a huge impact on the volume of gas because by changing the concentration, we are basically, changing the moles. So, and since you know that the calcium carbonate is in excess, so the limiting reagent in this case is the acid. So, so the moles of acid are very crucial for determining the volume of gas. So yes, this will have a major impact on the volume of gas. Smaller pieces of calcium carbonate are used. So this will also not have an impact on the volume of gas. Only the rate will increase. We'll get a steeper curve. The yield will stay the same, and temperature has also a similar effect. Only the kinetic energy will increase. The yield will stay the same. So we take if we draw the graph for option C and D, they will have the same shape like this, but the yield will stay the same for option number like C and D. And for A, the shape would be like this, because we are lowering the dilution. So, sorry, we are, diluting the acid. So A would have the shape like this. So so A and C, D are incorrect. Option B is correct, because this will definitely increase the moles of the acid, and we will get higher amount of gas. So B is correct. Let's move towards question number 5. In question number 5, there is a reaction between calcium carbonate and HCl, and the student wants to find the rate of reaction. So there are three combinations he can use. Combination number 1, in which he is recording the decrease in mass of the reactants in the flask after every 30 seconds for a period of 5 minutes. Yes, this can be used. And in option number 2, he is basically, measuring the volume of gas after every 30 seconds. The problem is that the duration of experiment is very low, very short. 30 seconds won't give you sufficient readings. So this is not reliable, so we won't go for it. 3. In the 3, he's counting the number of bubbles produced for a duration of 5 minutes. Yes, this will provide the student with good observations. So yes, he can plot a graph and note down the rate of reaction. So yes, this is also reliable. So we can go for 1 and 3. So if we look at the options provided, where 1 and 3 are mentioned, yes, it's C. C is correct. So 2 is totally incorrect. So option A and B are eliminated, and 2 is also again incorrect. So D is also eliminated. So the correct answer is C. Let's move towards question number 6. So basically, the question is asking about a catalyst. In this, sulfuric acid is added to zinc granules, and the reaction occurs, and a gas is produced. And that gas we definitely know is uh, hydrogen gas. I will just write the equation for you. Sulfuric acid plus what we will get is zinc sulfate and hydrogen gas. So he's talking about hydrogen gas. The other thing is that he has added a small amount of copper, and copper is unchanged. So copper is basically acting as a catalyst in this case. And which statement says copper acts as a catalyst? Let's look at the options provided. According to option number A, copper acts as a biological catalyst. Students, you know that only enzymes are the biological catalyst. Copper is not an enzyme. So option A is eliminated. I'll put a cross in front of it so that we can eliminate this. B. Copper lowers the activation energy of the reaction. Yes, this is true. Um, all the catalysts lowers the activation energy of the reaction. Yes, this is a true option. Now look at the other two. The rate of the reaction is greater as the particle size of the zinc is greater. No, this is absolutely wrong, because by increasing the size, only the surface area will decrease. So by decreasing the surface area, the reaction would slow down. So this is also not correct. Option number D. The rate of the reaction is greater if the pressure is increased. Students, pressure is only applicable on gases. And if we look at the reaction, zinc is a solid, and H2SO4 is also a liquid, an aqueous solution. So there are no gases involved. So pressure would have no effect on the overall reaction. So this option is also incorrect. So what we are left with, we are left with only option number B. So B is the correct option. I will circle B. Okay. Question number 7. In question number 7, students, the question is asking about the correct curve for the second experiment. In the first experiment, the student has, added carbonates to an excess, and sorry, the student has added excess carbonate to an acid and measures the volume of gas reduced at regular time intervals, and he gets a curve X. This curve he gets, but he repeats the experiments again by altering or changing the conditions. In the second experiment, he uses a 50 centimeter cube of 0.2 mole per dm cube acid. So students, in this we will first of all, the first step we have to do is to calculate the moles of the acid we used. Okay, let's try. For X, we will find the moles of the acid. Okay, let's find the moles. This is the formula for finding moles. Okay, the concentration is 0.1 in X and the volume is 100 centimeter cube. We will do the calculation. I will just cancel out the zeros to make the calculation simpler. And we are left, and the answer will be 0.01 mole. Let's do for uh, the second experiment. Second experiment. N is equal to C into V. The concentration is again, sorry, is 0.2 and the volume is 50. Let's calculate this. We are getting the moles 0.01. Now students, look, the moles are same. This clearly shows that the volume of gas will be same. The yield of the gas would be same. So A and B are totally incorrect as they are showing that the yield of the gas would either increase or decrease. So these are incorrect. We are eliminating these options. So what we are left with, we are left with B and C. So in the second experiment, the student has increased the concentration of the acid. So there would be a steeper gradient. In which option can we see the steeper gradient, B or C? Yes, it's definitely B. It has a much steeper gradient. So we will go for B. So B is the correct option because a concentrated acid has been used. Fine. Let's move towards question number 8. It's asking about the correct statement. Okay, students, we studied that enzymes are the biological catalysts which are made up of proteins. So let's look which statement tells us about enzymes. An enzyme is a biological catalyst that decreases the activation energy of a reaction. Yes, this is correct, but let's look the other options as well. An enzyme is a biological catalyst that increases the activation energy of a reaction. Incorrect. Enzyme always acts as a catalyst by decreasing the activation energy. This is incorrect. An enzyme is a compound of transition element. This is also incorrect because it is a protein. It is not made up of transition elements that decreases. Yes, this is also incorrect. It decreases the activation energy, but it is made up of a protein. This is also incorrect. An enzyme is a compound of transition element that increases. This is totally incorrect. So A is the correct option. Right. Let's move towards question number 9. As in question number 9, we have to, students identify the correct graph for the reaction between magnesium and hydrochloric acid. The equation has been already provided, and the question says that an excess of dilute hydrochloric acid is used. So basically, two graphs are being shown, one for the HCl and the other for the volume of hydrogen gas. Since we know that the amount of HCl or the concentration of HCl will gradually decrease with time. So all the graphs are showing this, but it won't go to zero because an excess of acid has been used. So option A and B show that it goes down to zero. I'll show you again. Option A and B show that it drops down to zero. So this cannot be possible because there is excess of acid. Only option C and D are correct because it stays little amount of acid stays after, still after the reaction. But what about the volume of hydrogen? According to option number C, it keeps on decreasing and there is no end to it. So this cannot happen. The reaction will definitely get stopped after some time. So this is also incorrect. So this is actually correct because the reaction stops. It gets flattens like this because all the volume of hydrogen gets stopped after some time. So yes, option D is correct since all of the magnesium has been used up. Okay, class. Question number 10. In this, what additional pieces of apparatus are essential for the investigation? As the question clearly reveals that there is a gas syringe. So what do we need further? Yes, we need a balance so that we can, measure the amount of calcium carbonate as well as, checks the decrease in mass of the reactants. Yes, we do need a balance and a measuring cylinder, yes, so that we can accurately measure the volume of hydrochloric acid so that we can pour into the reaction flask, yes, and stop clock so that we can measure the volume of gas at different intervals of time so that we can plot a graph and check the rate of reaction, yes. We also need a stop clock for this. So which option contains all these three options? Yes, it's definitely D. It has all the options in it. We'll go for D. The remaining options do not contain these apparatus, so we'll just eliminate these. Okay, question number 11. Which changes will speed up a chemical reaction? Let's look at the provided statements. Decreasing the pressure in a reaction between gases. This is incorrect because in gases, by increasing the pressure, the rate increases, but by decreasing the pressure, it will decrease. So yes, this is incorrect. Pressure has a significant effect on gases as particles are compressed more closer together, but by decreasing, the rate would definitely slow down. Okay, second statement. Increasing the size of the solid particles in a reaction involving solids. Yes, this will decrease the surface area. So this won't speed up the reaction by increasing the size. So this is also an incorrect option. Uh, Statement number three, increasing the temperature of any reaction. Yes, this will provide kinetic energy to the particles and they would collide more frequently. And yes, this is a correct option. We'll go for it. Increasing the concentration of a solution. Yes, the particles would be more crowded and they would react more frequently. Yes, this is also a correct option. So which option contains statement number 3 and 4? Let's look at the provided options. Not A, not B. Yes, it's C. We'll go for C. So this is the correct option for this question. I'll simply cross out the remaining options. Okay, let's move towards question number 12. In question number 12, students, a reaction has been given between magnesium and sulfuric acid. Two experiments are carried out in which the conditions have been varied. In the experiment one, the volume and the volume is 100 and the concentration is 1 mole per dm cube, whereas in experiment number 2, the volume is 50 centimeter cube and the concentration is 2 mole per dm cube. So there is variation in volume and concentration. For these types of questions, students, there is a tip. First of all, always calculate the moles of the solution or acid. In this case, it is acid. So for moles, the formula is concentration into volume divided by 1000. If the solution is in centimeter cube, yes, the solution is in centimeter cube. So let's calculate the moles for this question. Okay, for one, it would be 1 multiplied by 100 divided by 1000. And for 2, it will be uh, 2 multiplied by 50 divided by 1000. So what will we get? Let's calculate. I will, for simplicity, I will just cancel out the zeros and we will be getting 0.1. And in the same case, for experiment number 2, we will be getting the same number of moles. Since the number of moles are same, the volume of hydrogen gas would stay the same. So which graph shows that the volume stays the same by changing the conditions? Yes, it's A and B. C and D show that there is a change in volume. So these both are incorrect because according to the reaction, the volume of hydrogen is totally dependent on the moles of sulfuric acid. Since the moles are same, so the amount of volume would stay the same, but only the difference would come on the rate of reaction. Since in experiment number 2, the concentration is higher, the graph would be more steeper in this case. So let's look at option number A and B. In experiment number 2, there is a dotted line. So for we have to look for the dotted line having a steeper gradient. So yes, in A, there is a steeper gradient. The dotted line is having a steeper gradient. We'll go for option number A. Yes, the rate is higher than experiment number 2. So this is the correct option. Whereas in this option, experiment 1 has a steeper gradient. So this cannot possible because the acid is in lower concentration. This is wrong. So A is the correct option, students. Okay, question number 13. Again, this question has been repeated in the previous variant as well. So I will just circle the correct option for you. I won't repeat the explanation again. It is I previously explained this question in over here. This question has been repeated. It was repeated in 2021 and it again appeared in this variant as well. Okay, question number 14. Again, students, this is a reaction between magnesium carbonate and dilute nitric acid. The apparatus has been shown, and we are also provided with the chemical equation. Graph is also provided for our convenience. We just have to look for the correct statements in this question. The mass of the reactants and its contents decrease as time increases. Yes, as carbon dioxide gas is being evolved, so yes, there would be a decrease in the mass of the reactants in the flask. So yes, this option is correct. Okay, what about the second one? The rate of the reaction decreases as time increases. Yes, the rate decreases as we can see that the rate is highest till here, and then the line curves out. Over here, we can see that there is a decreasing rate, and then it flattens out. So yes, the rate of reaction decreases as time increases. This is the correct option. The reaction has finished after 4 minutes. Let's look at the graph. Yes, students, there is no change in volume of the gas. The change in volume is 0 after 4 minutes. So yes, This the reaction has finished, so this shows that no more gas is being produced. So this is the correct option as well. So which options contain all these three statements? We have to look we have to look at the provided options. So yes, this is definitely A. A contains all these options, so we'll go for A. Okay, students, let's look at the other question. Question number 15. In question number 15, basically there are two reactions. One is between sodium thiosulfate and hydrochloric acid, and the other is between nitrogen gas and hydrogen. So in the first reaction, the student or the examiner has increased the concentration of the both the reactants, and he's saying that the rate of reaction has increased. Whereas in the second one, he has increased the pressure, and he says that the rate has been increased. So we have to explain in terms of the collision theory, like what would happen. So if you look at the provided options A, it says that there would be higher frequency of collisions between particles. Yes, this is correct because concentration increases the collision. Yes, we will go for it. But what about the second one? Increasing the pressure. Yes, this should also increase the frequency of collisions. So this is also correct. But let's look at the remaining options as well. B B is right according to sodium thiosulfate and hydrochloric acid, but the activation energy in nitrogen and hydrogen will not be decreased because no catalyst is being used. So we'll just simply cross out all the options that are having the concept of activation energy. Since no catalyst has been used, I will cross all the incorrect options. So what we are left with A. So A is correct option because increasing the concentration and pressure basically increases the frequency of collisions. So yes, A is the correct option. So I have, attempted all the worksheet for you, and I've taught you how to solve questions of the rate of reaction. I hope you have understood. For any queries, you may ask me again. Thank you for your time. Uh, that's all. Allah Hafiz.